Consider the topology we have on screen. This is representative of the fact that we have a couple of departments within the same building that are connected to the same network. But we want, for performance reasons, for security reasons, we would like to keep the accounting traffic separate from the sales traffic. In other words, we want the accounting devices to be in their own broadcast domain. We want the sales devices to be in their own broadcast domain. And again, that can help us with security, and it can also help us with performance by dividing up our broadcast domains. Do you remember what the device is that allows us to communicate between broadcast domains? It's a router. And notice we have a router down at the bottom that's going to be able to route packets from the accounting to the sales domain and vice versa. A challenge that we have with this design, though, is that we've got a couple of floors in this building, and as a result, we've got a wiring closet on each floor, and the way we traditionally hooked up things when we were using hubs was that if we wanted to keep these networks separate, we would have a hub on the second floor just for accounting, and a hub on the second floor just for sales, and a hub on the first floor just for accounting, and a hub on the first floor just for sales. If we were to put a switch in place of those hubs, this is what it would look like if we had a switch on that second floor that was dedicated just to the accounting network. Let's say that this switch is a sales switch on floor 2, and this is an accounting switch on floor 2. We've got a sales switch on our first floor, and we've got an accounting switch on our first floor. Let's take a look at how traffic would flow in this network. If I wanted to talk from this top accounting computer to the bottom accounting computer, I would need to stay on the accounting network, the accounting subnet, the accounting VLAN we're going to be calling it. I would go into my accounting switch, which would go down to another accounting switch, which would go out to the destination computer. If I wanted to talk between this accounting computer and this sales computer, what would happen? Well, I would go into my accounting switch, and I would go through the first floor accounting switch, and I would go out to the router because I'm having to route between these networks. I'm having to route between broadcast domains. Out of the router, I would come back up into the sales switch for the first floor, and we would go over to that first floor sales computer. The point that we're making with this topology is that it's not a very efficient use of our switch ports. Notice that we have to have 2 switches on each floor, one for each of our subnets, one for each of our broadcast domains. What if we had another department? What if we had engineering? That's another switch per floor. That's not efficient. What we can do instead is train the ports on our switch to belong to different subnets, different broadcast domains, and we're going to call those broadcast domains VLANs, a virtual LAN. What we want to do is have a VLAN just for accounting, and we want to have a VLAN, a virtual LAN, just for sales. And when we assign the ports on our switches to the different VLANs, we get to consolidate those switches on each floor of our building. We can have just a single switch if we have enough ports, and that single switch can serve both the accounting and the sales VLANs. Let's take a look at what that topology would look like. In this topology, notice that we've consolidated our switches. We now have a single second floor switch, and we've got a port that belongs to accounting. I'll just label that as an A port. We've got a port that belongs to sales. Going down to our bottom switch, we also have an accounting port. We're assigned to the accounting VLAN, and another port that's assigned to sales. Going out to the router, we've got a sales and accounting port there as well. Let's label the bottom switch. We have a sales and accounting port. Let's take a look at the traffic flow now between a couple of our accounting computers. I want to go from the top accounting computer to the bottom accounting computer. I would go in the accounting port, a port that belonged to the accounting VLAN. I would go down to my bottom switch, and I would go out to that computer. What about going from an accounting PC to a sales PC? Let's say I wanted to go from here to here. Well, I would go in my accounting port. I would go down an accounting VLAN port to my bottom switch, out the accounting port that leads to my router. I would then route from the accounting VLAN to the sales VLAN, leave on a sales port, come back into the very same first floor switch, go out of a sales port, and we would make our way over to that sales computer. You see the big advantage of doing things this way? What we've done is taken a single switch and said some of the ports belong to sales, some of the ports belong to accounting, and as a result, we don't have to buy a switch for every single VLAN, for every single broadcast domain that we want to have in our design. We just train different ports to belong to different VLANs. Let's illustrate this further with an actual switch. Here we have a Cisco Catalyst 2960 series switch, and let's pretend that we take these first 12 ports and assign all of those to the accounting VLAN. And let's imagine that I've got a PC connected off of one of those ports. Maybe there's a server connected off of one of those ports. Maybe I have a printer connected, networked printer. Let's say I've got another port that goes down to a router. And because all of these ports belong to the same VLAN, a broadcast seen on one of the ports will be seen on all of the ports. Let's say that our next 12 ports belong to the sales VLAN. And we're connected to things like our sales PCs, we're connected to our sales server, and so on. Just like in the accounting VLAN, we also have a port that goes down to the router. So if we did want to communicate from, let's say, this PC in sales to this printer in accounting, here's what would happen. The traffic would go in to our switch port. It would travel across the switch backplane, go out of this egress port. It would go down to the router. It would then be routed to the accounting VLAN. We would go into this port. Again, we would travel across the switch backplane to our destination port. By the way, how do we know what the destination port is? Well, this is a layer 2 switch, so we're going to be looking at the destination MAC address to get us to an appropriate egress port on the switch. We would go out of that port and we would go up to the printer. That's how we would have traffic flow through a switch. Again, the big advantage here is that we get to carve up the ports on a switch. We get to say that some ports belong to one VLAN, one broadcast domain, other ports belong to another VLAN, another broadcast domain. Again, the requirement is to get from one VLAN to the other, we have to route. Some switches, by the way, like a Cisco Catalyst 3750, it's called a multi-layer switch. It can actually do routing inside of the switch. It's capable of doing that. But here, let's imagine that we just have a layer 2 switch, in which case we would have to have an external router. And a couple of the advantages of having a VLAN, of carving up our network traffic like this, are security, preventing traffic seen on one VLAN from showing up on another VLAN, and also performance. If we have lots and lots of broadcasts in our network, well, now those broadcasts will travel no further than the local VLAN. Now that we have a basic understanding of why VLANs are really important in our design, let's see how to set them up.